Hello, my name is Mitchell Winterhalter. I am from MSI Transducers Corporation. The Navy, through ONR, has asked MSI to increase the number of acoustic sensors in each size A sonobuoy with the system goal of increasing probability of target detection. MSI developed a new, innovative acoustic sensor from the ground up to meet the Navy's volumetric packaging goal, while also anticipating additional future program goals and needs. We reduced the size of the acoustic sensor by almost 50%, while simultaneously providing market improvements to almost every relevant performance metric, which we will dive into later. The unique acoustic sensor technology, with its low production cost, will enable application of high-density distributed arrays which augment target detection probability and range, enhancing the Navy's defense. A little background on MSI Transducers. We have been developing and manufacturing custom acoustic sensors of various complexity for over 30 years, working on applications from diver detection to torpedo homing. As evidence to MSI's current involvement with large Navy programs of record, we have successfully qualified and delivered several transducer and array systems, including, first, the high-frequency wideband array for the NSWC SQQ-32 mine hunting system. Second, the multi-frequency side-looking sonar array for Raytheon AQS-20A, which can be seen in the photo on the lower right of this slide. And third, the Archerfish nose array for the BAE Systems ASQ-235 airborne mine neutralization system, which can be seen in the photo on the lower left of this slide. MSI is fortunate to have extensive institutional knowledge, which can particularly be seen in the experience of Principal Investigator Tim Madari and transducer ceramics expert Barry Robinson, with 15 years and 20 years of experience, respectively. But it is also apparent through the rest of the company to the technicians, whose attention to detail is evidenced in the success of the aforementioned acoustic systems. This experience and expertise enabled MSI to successfully develop an acoustic sensor using our patented net-shaped injection-molded piezo-ceramic manufacturing capability. The U.S. Navy Size A sonobuoy is a small, expendable sonar system used by Navy forces to detect and track potentially threatening enemy submarines. The Navy has stated that they need a low-noise, sensitive underwater acoustic sensor for use in sonobuoy applications with reduced size to package more sensors into a fixed volume to increase probability of target detection. As the sonobuoys are often deployed from the air, out of Navy helicopters, as you can see in the image on this slide, the current package size of the sonobuoy is essential, so the only effective way to increase the number of acoustic sensors inside of each unit is to decrease the size of the sensors themselves. The transition target for MSI's acoustic sensor technology is PMA 264, Air Anti-Submarine Warfare Systems Program Office. The specification requirements for the new acoustic sensor are listed here, as you can see. The legacy acoustic sensor could not simply be scaled down, as reducing the dimensions of the sensor makes it physically challenging to meet the noise and resonant frequency requirements of the system. The size of the legacy acoustic sensor in light gray relative to MSI's new acoustic sensor in dark gray can be seen on the right. The dimensional difference is obvious. The length is decreased from 3.5 inches to 2.2 inches, and the diameter from 1 inch to 0.9 inches. But as I've said, this also presents typical physical challenges like increased noise and lower performance. And since MSI's acoustic sensor will enable the Navy to potentially more than double the number of sensors in each sonobuoy, each sensor also needs to cost less to hit the system-level cost bogey. MSI's new acoustic sensor technology solves for these challenges with unique design characteristics and manufacturing processes developed over the last 3+ years that make up our key innovations. The first key innovation is the design of the precisely optimized and tangentially poled ceramic cylinder to increase the sensitivity to size ratio from the legacy design. Second, to meet the low-cost bogey of $50 per acoustic sensor, MSI uses proprietary PZT injection molding ceramic manufacturing and automated fabrication and assembly processes for high-volume production. The ceramic cylinder is colored in brown in the lower right image on the slide. And third, the custom-designed and low-noise electronics to fit in the small package size as seen in green in the lower right image on the slide. All the requirements in the table are hit by MSI's new acoustic sensor, but one specification I want to highlight is how we beat the sensitivity requirement by a whopping 13 dB. MSI's compact low-noise acoustic sensor technology is currently at TRL 5. We have gone through several design iterations to optimize the acoustic and electrical designs and completed the Phase 2 SBIR. The acoustic sensor EDM, fabricated with representative tooling and processes, has been tested at Dodge Pond Navy Test Facility to verify performance. This data is shown in the table on the previous slide. MSI has also demonstrated these manufacturing processes to achieve the cost bogey of $50. The next step is to test MSI's acoustic sensors at a subsystem level by testing a partial array on an ONR reusable Sonobuoy testbed, which would enable MSI's acoustic sensor technology to move to TRL 6. The Fab Chart on this slide really sums up each major value proposition of MSI's new acoustic sensor for the size A Sonobuoy. You can read this chart left to right or right to left. Looking at the first row, the Navy's goal is to increase the number of sensors able to fit in the fixed Sonobuoy package size, to increase the resolution and detection capability of the sensor array system. This is done by increasing the sensitivity to size ratio of each acoustic sensor. MSI's design has this advantage due to its key feature of a unique tangentially poled ring. Looking at the second row, the feature MSI provides is a low noise solution. The advantage of this is good signal-to-noise performance, achieving a noise level below C state 0. The benefit to the user of MSI's acoustic sensor is increased probability, resolution, and range of target detection. Now, looking at the third key feature, low-cost manufacturing, MSI's injection-molded ceramic ring gives you the advantage of about 65% cost savings versus market average, while minimal part count and automated processing reduce touch time and labor costs. The benefit to the system user is more acoustic sensors for similar cost, which directly improves the sensor array system performance. MSI has biannual meetings with ONR and NAVAIR who are pushing for continued development and adoption of MSI's acoustic sensor technology. MSI will continue these efforts. Engagement with Sonobuoy system primes is essential. ONR is currently testing 30 of MSI's sensors on a partial Sonobuoy array. Once successful, the technology will reach TRL 6. Reaching TRL 6 will trigger ONR to configure a full-size Sonobuoy array for demonstration since the funding is already available. Upon successful demonstration, MSI's acoustic sensor technology will reach TRL 7 and will be ready for partnership with a Sonobuoy system prime such as a Rapsco. This process will also be accelerated as there is funding set aside for NAVAIR and a system prime to qualify the technology to TRL 8. The road is paved. We know there is a lot of work to come, but transition to fleet is the plan. Looking at the current market for MSI's compact, low-noise acoustic sensor, applications include, of course, Sonobuoy platforms, but also towed array systems and any distributed sensor array system. The application I've described throughout this presentation is based on a future naval capability with increased sensor count and performance, which is a full system upgrade. But there is also opportunity for simply replacing legacy acoustic sensors in the current Sonobuoy models, which would provide a lower cost solution in the same array configuration. There is always a need to provide the same capabilities at lower costs. The two current primary transition paths are through ONR and NAVAIR on the FNC next gen of Navy Size A sonobuoys, including the VADAR and ER DIFAR arrays, and the Arabsco DIFAR SSQ-53. There are many other potential applications and in transition paths for MSI's new acoustic sensor technology, such as NAVC surveillance distributed hydrophone arrays for towed and drifter systems. But the current path is sponsored by ONR with a transition plan in place at NAVAIR for implementation. Once MSI's acoustic sensor technology reaches TRL 8, MSI will need funding to continue production readiness efforts to produce the sensor at high volumes for less than $50. The production plan has been demonstrated representatively, so once funding is received, the plan will be executed. Thank you for taking time out of your day to come to my presentation on MSI's compact low-noise acoustic sensor. Please reach out to me or Principal Investigator Tim Madari with any questions or referrals via email or phone. Our contact information can be found on this slide and in the MSI Transducers virtual booth. One of us will be available during all business hours on March 23rd and 24th, so please do not hesitate to come by the virtual booth.